Okay, we're going to talk about solving compound inequalities. It's not too much more difficult than what you already know, but just a little bit different. So let's go ahead and get started. All right, so what's the difference between and or? Okay, well, and means there's an intersection. What do the items have in common? Well, right here is where they overlap. This is like a Venn diagram. I don't know if you've ever seen those before. Basically, this is all the solution A, all solution B. Here's where there's solution A and B, kind of a combination of both. Or means a union. If it's in one item, it is in the solution. Okay? So, or means it could be both of them, any of them. When we're looking for and, we're looking for just the specific space here. When we're looking for or, we can use any of them. Alright, so we're going to graph x is less than 4 and x is greater than or equal to 2. So the first thing we're going to do is we're going to graph x is less than 4. Well, on the number line, you remember from the video before and from the lessons before, it does not have a circle underneath, a line underneath indicating it's equal to, so it's just less than. So we're going to take an open circle right here, and then because our x is on the left side, our arrow points to the left. So we're going to go to the left. Now we're going to graph x is greater than or equal to 2. Well, now we have the arrow underneath, or the line underneath the arrow. So the line underneath the inequality sign, so we're going to go ahead and close that circle in. X is on the left again, and it points to the arrow. The tip of the arrow points to the right, so our line is going to go to the right. Both these things you should be able to do with no problems. This is not anything new. Okay, now we're going to combine the graphs. When you combine those graphs and we're looking for an and solution, we're looking specifically where they intersect. So where do they intersect? Well, they intersect here between 2 and 4, because here on the outside of 4 is only red, on the outside of 2 it's only blue. So the graph of x is less than 2 or x is greater than or equal to 4. So let's do that one. Let's graph. Actually, let's go back for just a second. I want to clarify this again. When we're looking for the word and here, this is our solution. Okay? It's got to be only the intersecting portions. Right here, okay, this is not part of the solution to that particular statement up there. Neither is this, because it has to include both graphs. And so in this case, this is our only solution. 2 all the way up to 4, but not including 4 because of an open circle. So let's graph x is less than 2 or x is greater than or equal to 4. Now we're looking at the word or. Okay, so here we go. So first thing again, like last time, we're going to graph x is less than 2. Okay, this time again, no line underneath, so we're going to do the open circle, and then our point of our arrows, because our x is on the left, is going to the left. We're going to go to the left as well. So let's graph now x is greater than or equal to 4. Now again we have the indicating sign right there. That means we're going to have a closed circle on 4. Our x is on the left, our arrow points to the right, so we draw our arrow to the right. Let's combine the graphs. Okay, now if you notice, significant difference here on the or problems versus the and problems. There's no overlap between the two graphs. So our solutions are going to be both of these. This and combines or is a union. Okay, that means we're combining these together in order you can be either this one or this graph. There's not going to be an overlap there. So which inequality describes the following graph? Well, if you notice up here, there's an inequality, there's a connection between the -1 and the -3 and then the line in between. So that should indicate to you that you're going to have an and graph. Okay, and since you're going to have an and graph, you have to think, okay, well, the numbers are greater than -3, not equal to, so the line shouldn't be under there because it's not filled in, so it's greater than -3, so it means the arrows are going to go this way, and it's less than -1, not equal to -1 because it's an open circle, so the arrow is going to go this way until it hits this one, and that's where your connection is. So y is greater than -3, okay, that indicates going this direction, all the numbers are getting bigger this way, or Is this an or? No, it shouldn't be an or because they're not connecting. How about y is greater than negative 3? Okay, still good. And y is less than negative 1. Okay, so all the line's going all the way down to until you hit negative 3. Okay, but the line doesn't keep continuing, so or is not a part of that. So the answer must be 2. And it is. Alright, let's graph the compound inequality. This is a compound inequality. This is the same thing as saying m is greater than 6 and m is less than negative 8. I'm sorry, less than 8. It's just a different, more easier way to write that. It can be rewritten as m is greater than 6 and m is less than 6 and graphed as previously shown. However, it is easier to graph everything between 6 and 8. Rather than taking a whole graph and drawing lines forever, the easier thing to do is take the 6, because it's not equal to, we just put a circle on the open circle on the 6, take this 8, and because it's not equal to, put an open circle on the 8, and then basically connect the two open circles. So that's what this statement right here is saying. It's easier to graph everything between 6 and 8 rather than to create two separate graphs and do two separate graphs. However, you may choose to do whichever method that's easier for you. If you feel like you need to graph two entire separate graphs, that's fine. Continue to do that, whatever it takes to get the right answer. Alright, so which is equivalent? Okay, we just talked about this. This is a different way to write. Negative 3 is less than y, and y is less than 5. Or you could say y is greater than, if you read it backwards, y is greater than negative 3, and y is less than 5. So y is greater than negative 3, or, no, this is not an or statement. Y is greater than negative 3, and y is less than 5. Be careful here, because this one says y is less than negative 3. All they did was switch the 3 and the y. You don't want to do that. The big side still opens to y here. The big side still opens to y. So our answer must be 2 again. It is. Okay, which is equivalent to x is greater than negative 5 and x is less than or equal to negative 1. I'm sorry, positive 1. And then again, it's also, this time it's having you write it. Okay, so does this say x is greater than negative 5? It does. So the big side, or the open side, opens up to the x. The open side opens up to the x here, so that one's good. Does this say that x is less than or equal to 1? Yeah, the point is pointing to the x. The point is pointing to the x here, so that looks like that's our right answer. Okay, and it sure is. Go ahead and take some time on your own to figure out why each one of these is wrong. The more you understand about this, the better off you're going to be as far as understanding this content. Okay, how about 2x is less than negative 6 and 3x is greater than 12, greater than or equal to 12? Well, we have to solve each inequality for x. Okay, so the first one we're going to solve is this one. We're going to divide both sides by 2 to get x by itself. X is less than negative 3. Now we're going to solve the next one. So we have 3x is greater than or equal to 12. Divide both sides by 3 here. X is greater than or equal to 4. So now we have a new statement. We should have the statement of x is less than or equal to, less than negative 3, or x is greater than or equal to 4. So we're going to graph both of them. Combine our graphs. And there's our solution graphed. Again, notice the or, in this case and, they go different directions. Now, what's the problem here? Okay, they don't intersect, do they? So because they do not intersect, they are no solution. X cannot be greater than or equal to 4 and less than negative 3. That's impossible. Therefore, you have a no solution. This is an or graph, isn't it? Alright, so let's graph 3 is less than 2m minus 1 less than 9. Okay, this is a little tricky. Okay, this has got more information in it now, and we don't have a single variable. So the first thing we're going to have to do is understand that when it's written like this, it is an and problem. So this is 2m minus 1 is greater than 3, and 2m minus 1 is less than 9. So we can solve each inequality to get m. And again, we're breaking apart the inequalities to create two separate ones. And what you end up with, to kind of cut to the chase, is 2 is less than m and m is less than 5. Okay, so there's our graph. So here's 2, open circle because there's no line underneath it. M is greater than, that means it goes to the right. Here's 5, open circle on the 5 because not equal to, and everything to the left. And we're just graphing the union. Okay, so we're going to graph x is less than 2 or x is greater than 4. There it is again. Go to 2 on our number line, open circle because there's no equal to. It goes to the left because x is on the left, pointing to the left. On the or portion, you go to 4 on the number line, colored in. X is on the left, but the arrow is pointing to the right, so go to the right. Okay, and notice on these ors, there is no specific special way to write these like there is with the and. Okay, you can't combine these terms. The or is going to be in there. Now, this one, you have x is greater than or equal to -1. So go to -1. Okay, you got your closed circle, and it goes to the right because the arrow is pointing to the right. On this one, you got x is less than or equal to 3. So you go to 3 on your number line. That would be right here, and it would be a closed circle pointing to the left. When you graph this, you'll notice that it's going to overlap everywhere. So the whole line is going to be shaded. Okay, so keep that in mind. All right, and that concludes our thing for today. So one thing I do want to mention is to make sure that you pay close attention on how to solve these. There's going to be another way that I'm going to show you how to solve compound inequalities. I will do that in class, just kind of give you an example, just a real kind of a shortcut way to do it. Other than that, this is your introduction to compound inequalities. Hopefully with this, you should be good enough to understand the little slight differences between regular inequalities and compound inequalities. We'll see you guys in class tomorrow.